Module 9.1, solving equation by taking square root. Essential question, how can you solve square root equation using square roots? Isolate the square root on one side of the equation by adding, subtracting, multiplying, or dividing. Then take the square root. Finally, solve for both the positive and negative square roots. So it's very important that your answer must be containing a positive and a negative square root. Exploring square roots. Recall that square root of a non-negative number a is the real number b such that b squared equal to a. Since 4 squared equals 16 and quantity of negative 4 squared equals 16. The square root of 16 are 4 and negative 4. Thus, every positive real number has two square roots, one positive and one negative. The positive square root is given by square root of 8, and the negative square root is given by negative square root of a. These can be combined as positive negative square root of a. Properties of radicals. Property. Property of radicals. For a greater than or equal to 0 and b greater than or equal to 0, the square root of the product a times b equal to square root of a times square root of b. Example, square root of 36 can be written as square root of 9 times 4 is equal to square root of 9 times square root of 4. Square root of 9 is 3, square root of 4 is 2, so 3 times 2 is equal to 6. Quotient property of square root. For a greater than or equal to 0 and b greater than 0, square root of a divided by b equal to square root of a divided by square root of b. For example, negative square root 0.16 is equal to negative square root of 16 divided by 100 equal to negative square root of 16 divided by square root of 100 equal to negative 4 divided by 10, and 4 divided by 10 is negative 0.4. So here are some examples. So for a, we have a positive negative square root of 49, which can be written as positive negative square root of 7 squared. So this can be a plus or minus square root of plus or minus 7. Part B, we have a plus or minus square root of 25. So similar to part A, can be written as 5 squared. So the answer will be plus or minus 5. And for 12, we need to use one of the property. So 12 can be written as square root of 4 times 3, and can be written as square root of 4 times square root of 3. And since 3 is a prime number, so we will leave it as square root of 3. And square root of 4 can be reduced to 2, so it says 2 square root of 3. And part D, plus or minus square root of 16 divided by 9 can be written as square root of plus or minus square root of 16 divided by square root of 9. And square root of 16 is 4, and square root of 9 is 3. Now for E, we have to change this into a fraction, so then plus or minus square root of 27 over 100. And so then be written as square root of 27 divided by square root of 100. But square root of 27 is the same as square root of 9 times square root of 3 divided by 100. And square root of 9 is 3. Square root of 3 is just square root of 3. And square root of 100 give us 10. Right, so now for part A, explain why square root of 6 squared and square root of negative 6 squared have the same value. Oh, square root of 6 squared is the same as square root of 36, which we know is 6. And square root, well, negative negative 6 squared is also 36, so this is 6, so they have the same answers. And for number 2, explain why a must be non-negative when you find square root of a. Well, we're saying that when we have a square root of a negative number, right, so then this would give us a non-real number. So, okay, so then do we see that there's no real solution in the no solution in the real number system. For number 3, does 0 have any square root? Explain why or why not. Well, 0 squared is still 0, so square root of 0 is always a 0. So then, yes, 0 does have a square root, right? And well, plus or minus 0 is still a 0. Okay, so solving ax squared minus c equals 0 by using the square root. Solving a quadratic equation by using square root may involve either finding square roots of perfect square or finding square root of numbers that are not perfect square. In the latter case, the solution is irrational and can be approximate. Solve the equation. Give the answer in radical form, then use a calculator to approximate the solution to 2 decimal places, if necessary. Use a graphing calculator to graph the related function and compare the roots of the equation to the 0 of the related function. So example A, we have 4x squared minus 5 equal to 2. We want to solve for x. So our first step is to plus 5 from both sides. So now we have 4x squared equal to 7, and then divide by 4 on both sides. Right, so then 4 divided by first one, we have an x squared equal to 7 over 4. And now we're going to take the square root of both sides. Now, every time when you do a square root, always add in the plus or minus. That's the square root and the square they cancel out. So we have x equal to plus or minus square root of 7 over square root of 4. And square root, since 7 is a prime number, so we just leave it as square root of 7. And square root of 4 can be reduced to 2. So this is your answer in the square root form, and we call this our exact solution, right? So the next slide will show us to use the calculator to approximate the answers. Okay, so here we're using the calculator. So the approximation for x is approximately 1.32 or negative 1.32, or you can use a graphing calculator to find the x-intercept. So this point is for this point, and the negative 3.32 is for this one here. Right, and then part B, solve for x. So similar to the previous example, so we're going to add 8 to both sides. So we have 2x squared, negative 8 positive becomes 0, equal to 0 plus 8 gives us 8. Divide by 2 on both sides of the equation. So we have x squared equal to 8 divided by 2, and 8 divided by 2 can be reduced to 4. So we have an x squared equal to 4. So solve, we take the square root on both sides. And whenever we do the square root, it's always plus or minus. Right, so this reduces to x, so x equal to plus or minus 2. Okay, and then here once again we can use our calculator to graph for the answers. Right, so this is our x-intercept for the positive 2, 0. This is our x-intercept for the negative 2, 0. Okay, so these are called the root, or sometimes they call it the 0 of the function. Right, okay, and so now your turn to solve for x. So I'm giving you guys 1 minute per question. Okay, so make sure that when your right answer is plus or minus 3. Now, for this answer, we have x equal to plus or minus square root 11 over square root 5. So then 11 is the prime, 5 is a prime, so both give us an irrational answer. But then we cannot have a radical 5 in the denominator. So that means that we need to what we call rationalize this. So by multiplying our expression by radical 5 over radical 5. Right, so this gives us plus or minus square root 11 times 5 is 55, and square root 5 times square root 5 is square root of 25. But square root 25 can also be reduced, so it's over 5. Okay, so this is our answer for number 5. Okay, so then let's go to a different form of solving our square root. So the form now is a parenthesis x plus b equals c by using square root. Okay, so like example 2, solve the equation. Give the answer in radical form and then use a calculator to approximate the solution to 2 decimal places if necessary. Right, so we want to get x by itself. So our first step is to take the square root to eliminate the square. So when you guys do this, make sure that you carry the parenthesis with you. Right? So we see that the square root and the square, they cancel out, so we have an x plus 5. Now be careful here, this is going to be a plus or minus 6. Okay, so plus or minus, that means that we're going to have 2 equations. So you're going to set this up as x plus 5 equal to 6, or x plus 5 equal to negative 6. And now solve for x by minus 5, so x equal to 1, or minus 5, so x equal to negative 11. So we should have 2 answers, x equal to 1 or x equal to negative 11. Right? Okay, so let's try our part B. So similar to the previous one, but we want to get the square by itself. Right? So your first step for this part is you're going to divide by 3, divide by 3. So then you're going to have an x minus 5 quantity square equal to 18 divided by 3, which gives us a 6. And now to get at the square, we're going to take the square root of both sides, but make sure that you include the plus or minus. So the square root and the square, they cancel out. So we have an x minus 5 equal to plus or minus square root of 6. And square root of 6, just leave it as square root of 6, right? Because square root of 6 is the same as square root of 3 times square root of 2, but we cannot reduce those. So then to solve it, you can set this up as x minus 5 equal to square root of 6, or x minus 5 equal to negative square root of 6. So your answer is going to be x equal to 5 plus square root of 6, or x equal to 5 minus square root of 6. And it's okay to have your answer in this form, or you can use your calculator to change it into a decimal. Right? Okay, so now we want you guys to try this one now on your own. Find the solution, if any, of 2 parentheses x minus 3 squared equal to negative 32. Right, so the first step is to divide by 2 on both sides. So we have x equal to 3 square root of 2 equal to negative 32 divided by 2 would give us a negative 16. So now we can take the square root on both sides. Right. So that's redo x equal to -3 equal to, well, this part here, we have a square root of the negative numbers. Okay? So then we see that this way we have no real solution. Okay, so let's try these on your own. Okay, so make sure that you include the plus or minus, right? Or if you want to, for number 7, you could have written as 10 plus or minus square root of 6. Right. Okay, so let's go on to number 8. Right, so for number 8, then we have the square by itself. So then you would just take the square root of both sides. Always include plus or minus when you solve for it. So the square root cancel out, so we have x minus 9 equal to plus or minus square root 64 give us an 8. So you're going to set up x minus 9 equal to 8, or x minus 9 equal to -8. So the answer is going to be x equal to 17 or x equal to 1. Okay, so then that was day 1 note. So then this is going to be day 2. So then we can have 2 day notes in one video. Right? So example 3 said that a contractor is building a fence in a playground at a daycare. The playground will be rectangular with its width equal to half its length. The total area is 5,000 square feet. Determine how many feet of fencing the contractor will use. Right, so we see that sand is a rectangle. That means that we have length and width. Right, and we're given that the width is half of the length. Right, so that means that this is going to be 1/2 times L. We know that the area is always length times width, or in this case, L times 1/2 L, which gives us 1/2 L squared. And we're given that the area is 5,000 square feet, so we have 5,000 equal to 1/2 L squared. So to solve it, we're going to times by 2/1 on both sides to eliminate the 1/2. So then we have 1,000 equal to L squared, and to solve it, we take the square root on both sides. Okay, notice that I did not use the plus or minus because since L is the length of a rectangle, so we must use a positive. So that means that your length L is going to be 100. But the question asks us to determine how many square feet of fencing the contractor will use. This means that we're looking for the perimeter. Right? So then we see that the equation for the perimeter is 2 times the length plus 2 times the width. Okay? And so then we know that the length is 100 feet, and we see that the width is 1/2 of the length length, which means that 1/2 of 100, which gives us 50. So then here we say that 2 times 100 plus 2 times 50 equal to 200 plus 100. So then the perimeter, we need 300 feet of fencing. Okay, so let's try part B. It's saying that a person, let me fix this for a minute. Okay, see that a person standing on a second floor balcony drop a key to a friend standing below the balcony. The keys are dropped from a height of 10 feet. The height in feet of the keys as they fall is given by the function h of t equal to negative 16t squared plus 10, where t is the time in seconds and the key are dropped. The friend catches the key at the height of 4 feet. Find the elapsed time before the key are caught. Right, so here we're saying that our equation h of t equal to negative 16t squared plus 10. So the friend catch the key at 4 feet. That means that you're going to have 4 equal to negative 16t squared plus 10. So to solve for t, we're going to subtract 10 from both sides. So here we have a negative 6 equal to negative 16t squared. And to solve for t, we're going to divide negative 16 on both sides. So negative divided by negative is a positive, so it gives us a t squared. And this negative 6 divided by negative 16 can be reduced by 2, so it gives us 3 over 8. And to solve for it, we can take the square root. 3 over 8 equal to the square root of t squared. So since t is going to be always measured in terms of a positive number, so then we're not going to choose the negative, right? So then this gives us t, and as you can see the answer on the left, so then square root of 3 over 8 is approximately 0.61, and this is in terms of second. Right, okay, so this is your turn. It's similar to our first example on day 2. So a zookeeper is buying fencing to enclose a pen at the zoo. The pen is an isosceles right triangle. There is already a fence along the hypotenuse, which border a path. The area of the pen will be 4,500 square feet. The zookeeper can buy the fencing in whole feet only. How many feet of fencing should he buy? Okay, so first draw an isosceles right triangle. So then let's say we have something like this. Okay. And isosceles, that means that these two sides are the same. So we can call this the base and call that the height. Right? So we say that the area of triangle is always 1/2 base times height. Okay, and since the base and height are the same, so we can call both of them being x, so this is 1/2 x times x, or 1/2 x squared. Right? And we're given that the area is 4,500, so we can rewrite it as 1/2 x squared equal to 4,500. So times 2, so then x squared equal to 9,000. To solve, we take the square root. Cancels, and x is the size of a triangle, so we're going to just use the positive. So then the answer x is going to be 30 feet. But then here the answer to look for to buy the fencing for the triangle. That means that they're looking for the perimeter. Okay, so then let's go back to our triangle. I'm looking for some space here, so let's see. So we can have this as for our triangle, right? So then this is 30 and this is 30, so we need to solve for the, let's call that the hypotenuse, right? So then we can see that this is 30 squared plus 30 squared equal to hypotenuse squared. Oops, I think I did something wrong here. Give me just a minute. Okay, I think there's a mistake here, so let me go back and fix this. Or it's not, I thought it was, this is 9,000, not 900. Okay, so then this will give us a x equal to square root. Let's write it as right now as square root of 9,000. So then now we have an isosceles right triangle, so this is square root of 9,000, and this is square root of 9,000 as well. So to find the hypotenuse squared, so then we have a square root of 9,000 squared plus square root of 9,000 squared equal to h squared. So this gives us 9,000 plus another 9,000 equal to h squared. So let's see, so this gives us 2 times 9,000 equal to h squared. So let me use a calculator for that. Okay, so then let me round this off. So the square root of 2 times 9,000 equal to square root of h squared. So this gives us 134.16, and then they want everything to be whole numbers, so I'm going to round this off to, so the hypotenuse is 134, right? So let me see some room here. So then we see that the square root of 9,000. So I'm going to round this off to 95, and this is 95, and this is 134. So then the perimeter will be 95 plus 134. So it will give me 324 feet. Okay, and we're getting close to the end. So it's that how many real solutions does x squared equal to negative 5 have? Right? So then we see that there's no real solution for this part, because when we take the square root, we cannot have a square root of a negative number. Right? And for number 11, they say that suppose the function x of t equal to negative 16t squared plus 20, model the height in feet of an object after t second. If the final height is given by 2 feet, explain why there's only one reasonable solution for time it takes the object to fall. When we measure time, it's always in terms of a positive. Okay, so then your equation you set up is to be negative 2 equal to negative 16t squared plus a 20. And then the time is always must be in a positive. Okay, and then for number 12, so that what steps should you take to solve this equation? So your first step to do is to add, let me change to a different color. So we're going to add 54 to both sides. So you have 6 squared equal to 96, and you're going to divide by 6 on both sides. So we have x squared, and so this give is going to be reduced by 3, so it's going to be 32 over 2. Right? And then 32 over 2 can also be reduced by 2 again, so then this is going to be 16. So then to solve it, you can take the square root on both sides. We have plus or minus, so then we x equal to plus or minus 4. Right, so that's the end of our note for module 9.1. So these are the summary. Solving quadratic equation by using square root when the equation has no real solution. This is because when you do x squared equal to negative 81, and we see that there's no real solution. And when you set this up, so it's minus 81 from both sides. When you have x squared equal to 0, then you have one solution. And when you have an x squared equal to a positive number, then you would have two solutions. Right? So x can be plus or minus 9.